project rather than a tutorial project, but we're going to use this to sort of show off the editor. Yeah, I'm using Unity 4 because it's the most recent version. As a matter of fact, I think I'm using Unity 4.1, which is not quite out yet. So you guys can see a tiny sneak peek. It really is all under the hood stuff, so there's very little difference between 4.1 and 4.01. Most of the tutorials out there are in 3 or 3.5 purely because of just the age, is that it takes, we had 2 years to accumulate in the community and 2 years to accumulate in Unity Technologies 3.x tutorials, and we're now beginning to roll out 4.0 tutorials, and I'll talk to you more about that in Q&A. We can talk about the Learn section of the website, which there's some sneak previews of on the blog, and you can see what's coming out for the 4.0 cycle. So when we're dealing with the Unity editor, which is what we see here, Unity works in a series of windows or views to be able to create and manipulate the object, create our games and manipulate the objects in our games. So I'm going to go over each one of these windows and views very briefly, and then I'll come back and go over them in detail. So there's the project view, which is the 2-column view that we have here, and the project view is where we store our assets. Our assets are hard files. They're asset files that we import from other applications. There's the hierarchy window. The hierarchy window over here is where we store a list of our scene objects, and that works very closely with the scene view. We can see that if we select something in the hierarchy, which is the list of all the scene objects, it's highlighted in the scene view, so we can see it. If we pick something out of the scene view, it's then highlighted in the hierarchy, and in both cases, we then observe that object here in the inspector. We can inspect the object. The inspector is where we see details of the object that we have selected, the scene object that we have selected in both the hierarchy and the scene view. There's the game view. The game view is where we're looking through our game view camera rather than our scene view camera, and where we can play and test our game, and we can see if there are any errors. We can see what the game is like, exactly the way our players would on their platforms. Then there's the console. If the console isn't exposed, you can go ahead and pull it out from the window, Windows Console, or Shift Command or Shift Control C, and that brings up the console. The console is where errors and information are displayed when we're running our game, when we're writing our scripts, and we can also give ourselves messages. These are messages that have been written in by the developers to sort of track the progress of the game. And then the whole editor environment is rearrangeable, dockable, and we can save our layouts. So let's talk about the project view. What are the specs of my computer? Very old! 2007 era Tower. So it does have 8 cores, but and a new graphics card that I got for Christmas. Unity gave me a Christmas present of a new graphic card, so it's not too bad. The project view. This is a view into the project's assets directory. And this is where the developer can import and store and organize their assets. Now, assets are imported objects from other sources, like models or textures or sounds from other applications, or they're objects created directly in Unity, from like prefabs, scripts, or materials. And you can do that from the Create button down here. You can create new scripts, new shaders, prefabs, and materials. And that's the same as coming up here to the assets menu, and picking Create. It's the same menu, but this one is in the proper OS menu. It's true for both Windows and Mac. And then down inside the editor is the same menu here in the same order. Now, a quick note about this particular view. The project view is a little bit different from all of the other views. The project view isn't owned by us. It's a punch through into our assets directory, and when we see the contents of this view, we are actually talking to our operating system. So if I go ahead and take a look at the, oh yes, I've been fussing with the most recent Humble Bundle. Those aren't supposed to be on my desktop. Let me get rid of those. Yes. Games. Bing, bing, bing. Gone. So if we look at Angry Bots, there we go. It's in the other window. There we go. and we look at the contents here, this is we're looking into our project directory now. Now all of these files and all of these directories, so essentially everything except for the assets directory, are simply being dealt with by Unity, and we can ignore completely. Now the assets directory, on the other hand, is where we are free to do anything we want to. And if we take a look at the content of the assets directory, these are where all of our assets are being held. These are our models, our textures, our sound, and our scene files. And if we come back and take a look at Unity, we can see that this is the exact same content that we have here. And if we go into single column mode, and this can be in single column or double column mode, and I'm going to put it over to the side so we can just get a better look at it. We can see that the contents here are exactly the same as the contents we have here. So this is essentially just simply a punch through into the project, into our assets directory on our operating system. I'm going to go back to the previous layout that I had before. And as such, since we're punching through to the to our assets directory, there are a couple important things to know. We can add new files to our anywhere into our assets directory, any of our subdirectories in there, and if it's a supported file within Unity, Unity will just go ahead and import that asset. We can go ahead and make changes in third-party applications like, say, Photoshop or Blender or Maya or Max or an audio application, and we save our changes. Unity will sense those changes and re-import that object with the changes included. On the other hand, Unity is keeping track of all of the information that's going on in here with all of these other files. So one of the most important things that we don't do is reorganize, reorder, or rename any of our assets on the operating system level. So when we're on our desktop, we're fussing around with files on our hard drive, don't change, reorder, or reorganize existing files here. Do that all inside Unity with Unity running. Now Unity is smart and it can rebuild if it makes a mistake, or if we make that mistake, if Unity can rebuild it, but it's not worth tempting fate, and so just go ahead and do all of your reorganization and renaming inside Unity, and simply use the assets directory to add new files to or to save over existing files. Yes, I have lots of games. I just had to delete them, since not delete them, just taking them off my desktop, since those were just disk images. I just didn't want to distract us from what we're doing. Solar 2 is a game. It's a Humble Bundle. We can talk about that in Q&A. Some nice stuff there. And OBJ files and Cinema 4Ds files are supported by Unity. Yes, unfortunately, we're not doing a 102 class this week because I'm prepping for GDC in 2 weeks. Otherwise, we can go over that, but we can talk about import pipelines during Q&A. But we don't really have space for it today in this lesson. So once we have our assets, we've imported our assets, we can add these objects into our scene, and we see that over here in the hierarchy. The hierarchy, it works very closely with the scene view, as we've seen before. Anything that we select in our hierarchy, which is a list of all the game objects in our scene, then we can see it in the we can see that in the scene view. Anything that we pick out of the scene view, we see in our hierarchy. So essentially, this hierarchy is a view into the contents of our current scene in alphabetical hierarchical order. And these objects are instances of our assets, and so they're either assets that we take from our project view, or they're assets that are created directly in the scene from templates within Unity. And we can do that from here. We can create new game objects, and these are from this menu we create new game objects directly into the scene. And that's the same thing as coming up here to game object, create other. And so we can create new game objects directly into our scene using one of these two identical menus. Now, the scene view is hierarchical and alphabetical, and it's used to define the organizational relationships between objects in the scene. And we'll sort of see this more going forward. So before I go in and talk about the scene view, let's talk about scenes themselves. What is a scene? Scenes are usually what people think of as a level, and many people sort of interchange level and scene, one scene per level, one level per scene. Well, scenes can contain one level and only one level, but this isn't necessarily the only way to deal with scenes. What is a scene? The scene itself is actually the volume that we're creating our 3D game in. everything within our scene exists within this game. We load everything within the scene into our device to be able to run it. And so if we're dealing with a simple level like this, this is all that we see. But if you imagine that we have an open world, we'd be streaming in new assets into that scene as we moved around. We'd be dumping assets out of that scene as we no longer needed them to keep our device, so we could free up the resources for our device. And you can also have multiple, what many people call levels per scene, if you think about it. Imagine that this was a scene, or sorry, a level where our character had to get through a maze and then reach the end and was given a score, and we told them how many secret doors you found and what your score is and whether you got the boss monster. And then when they're done, you go to another level. Well, you could have one level per scene, but you could also, if you wanted to, put multiple versions of this in this scene, and when the character is done with the maze, just teleport him over to the beginning of a new maze and have him go through that. So you could have multiple game levels sitting in the same scene, and you'd only load one scene with, say, 2, 5, 10, 20 game levels into it, whatever the resources of your platform could handle. No stupid questions. If we had multiple levels, would they each have to have their own separate scene? No, like I'm saying, no, they don't have to have their own separate scene. They could. It all depends upon how you want to manage your resources. An example is if we had 10 of these mazes in this particular scene, we'd have to load them all in, even if we made some of them inactive. And so you'd be having a longer load time for those 10 scenes. You'd be using up more resources holding on to all of the information for those 10 scenes. But at the same time, then if you move from scene to scene, there would be no load time. It would be very, very fast. And I've seen some games that I presume do this, where you start off with, say, you load the gold box full of puzzles, and each puzzle loads really, really quickly. And then when they get done, they go, yeah, you've completed, the first 25 levels. Let's load the blue box. And they load up the blue box, and you can play those relatively quickly. And my assumption is the way that they've done it is that they've loaded they will load 25 levels at a time into a scene, and then reload that when they reach the end, if that makes sense. Now, you also don't need to include scenes in your final build. I was working on a game the other day where I wanted to look at a number of models side by side in a bunch of different lighting environments. So I simply created a new scene, put in all the models, put in all the lighting, made a very simple UI for turning these on and off, and then tested everything I needed to side by side, and didn't need to include that in the build at all. And this to me was better than, say, dropping these models into an existing scene in the game, because if I forgot to remove one, there would be a nice Easter egg for my player, come around the corner and see something that I had put in the game as a test one afternoon and then simply forgot to remove. So it's not really sometimes the smartest thing to do to start monkeying with your proper game levels. So just create a new scene, use it for doing your tests, test beds, test out things, and then simply never include that scene in your final build. Now the scene view itself up here, this is a view that allows the developer to see an overview of the game's current scene and all of the objects in that scene in the 3D scene world. It's a view that allows us to move and manipulate our assets in the 3D world. Now, usually the first thing that people will discover is that if you hold down the arrow keys, you can fly around the level, and you stay on a plane, and the camera maintains its facing. You're staying on the XZ plane, and as long as you hold down a key, you fly faster and faster and faster and faster, and then you stop when you let go. And then this really isn't the most common way of moving. It's good to know that you can do it, but the most common way of moving is up here, the little hand tool. Now these 4 buttons up here, these are shortcuts for manipulating things in the scene view. The hand tool is for manipulating your scene view camera, and the other 3 are for manipulating game objects in the scene. The shortcuts are Q, W, E, and R, so the top left-hand buttons of the editor are also the top left-hand buttons on a common QWERTY keyboard. So a persistent multiplayer world would just have a single scene aside from instances. Usually that's the way that it's done, is that you just have one simple scene, and you're finding ways to add assets in and remove assets out. And there are also some tricky bits to keep from getting too far away from world origin, because most of these things are all associated through a series of numbers. And when you get farther and farther away from origin, you lose your what's called your floating point decimal space. And so you can start to get small errors the farther away you get from the center of your game world if you get extremely far away. So on very large worlds, there also have methods of resetting everything so that you also stay in the center of your level, even if your character has apparently been traveling a long, long way. But that's we can talk about that in Q&A. There's a whole bunch of interesting issues around getting multiplayer worlds working, and different both Unity and third-party solutions to that as well. So when moving the camera, the quick and best thing to do is to hold down the Q key or touch the little hand. And with that, and then you can use the left mouse button, and you simply pan along whatever the current plane is of your camera. So if you're angled down, you're angled over, you'll be moving along that plane. If you hold down the Alt or Option key, you will rotate. And if you hold down the Control key, you will zoom. And this means that you can then move around your scene by doing things like rotating over and then zooming in, and then you can pan along and then pan down and zoom around. So essentially using the Alt or Option and the Control keys and then the left mouse when you're in the hand mode, you can pretty much move around your scene in any particular way that you want to. So zooming, rotating, and panning your camera. When you're using the right mouse button, you'll then look around as if so it's centered, so you're pivoting on the camera itself. But if you're using that's the right mouse button, and if you're using the left mouse button and the Option, then you pan around a center point, usually the thing that you are focused on. So the other thing you should look at is F for frame selected. Frame selected means that you'll jump to any particular object. So you can pick any object and hit F, and it will be, some people call it focus, but the official name is frame selected. And so not only can you pick objects out of your scene and then hit F for frame selected, but you can also pick objects out of the hierarchy, and even if you don't see it, frame selected will jump you to that object. Once you have an object, you can use the W, E, and R keys to manipulate its position, its rotation, and its scale. Now, excuse me, when you're dealing with a center point, you can move things along their axes. And when you're dealing with the center point, when you're dealing with moving the position, you can move along a plane, XZ, XY, YZ planes. Rotation, it becomes a free rotation in the center. And then with scale, it becomes uniform if you then try to scale from the center. You can search both the project and the hierarchy with the search fields. When we're searching the hierarchy, say we're going to look for our player, we can see everything that is returned with the word player in it. If you click it, you'll see a path that gives us the path to the object. And if we look out, the whole game world has gone gray, except for the objects that have returned in our search. So if we look at these different objects, we can see that the whole world has gone gray, except for the objects that we have in our search. So we can go ahead and pick out the player. F for frame selected, we zoom in, and there's our player. If you want the game world to come back, we can simply clear that search field, and we get all that gray goes away. Excuse me. Now the inspector view, it allows, this view allows the developer to see an overview of the entire game object and its attached components. And we can see and manipulate the exposed values on the properties of these components. So if we look at our player here, this is our player game object, and we are inspecting him here in the inspector, and there's a header that includes whether the object is active in the scene. It's the name for the player, or the name for the object, tag, layer, prefab, other settings up here, some of which we'll cover in a moment. Then there are attached components. This is the transform component. Transform component keeps track of the position, rotation, and scale of the object. So if we go ahead and try to move the object, we can see as I move the object, grabbing it along an axis, we can see that the position is changing in the transform, but I can also change the position. I'm doing this by grabbing the title. If you grab the title, you get a nice smooth movement. As we move the title, we move the values here, then the object is also updated. So you can either move the object and it will update the transform, you can move the values in the transform and it will move the object. And this is true also of rotation and scale. There's the capsule collider. The capsule collider is a component that controls collisions. That's the little green cage that we see on the outside. Now we could be using the blue cage of the mesh to do collisions, but it would be incredibly complicated. The math involved for that would make the entire game slow down, so it's not efficient. So we're going to be using a capsule collider. So we put a very simple collision volume around our character, and that's what we use to calculate our collisions with. There's a rigid body component, and that enables gravity on this the character. So we get mass, we have drag, we use gravity. That's all enabled by the rigid body. So essentially you have this empty game object and you start adding components to it, and each one gives it slightly more complicated behavior. Underneath are custom scripts written by the developers of AngryBots that keep track of movement and health and things like the footsteps. And so those are custom scripts attached down below. Yes. Excuse me, I got a frog in my throat. Give me 2 seconds. Yes, you can, and we'll talk about that later on, but essentially that's the difference between this button, but we'll go over the details of that later on, where I'm in local mode, but if I wanted to be in world global mode, I just would change that to global. But we'll go over that in slightly more detail a little bit further on. Now, game objects. Game objects are holders, game objects are containers. Game objects can hold components on them. We can see that there's a number of components on this player game object. But game objects can also hold other game objects in them. And if we go ahead and take a look at the player down here and turn down the little arrow, we can see that inside the player, and this is why the hierarchy is called, well, is called what it is, it's hierarchical, is that this game object, the player, holds other game objects as children. And one example is here is the blob or blob shadow. We can see that over here. And so we've got this blob shadow game object. I found a good view of it when I was finding myself in the scaffolding there. And so there's this blob shadow that is a child object of the player. Now, one of the most important things to know about these game object families, where you've got one game object holding another, is that the transforms, or position, rotation, and scale, of all of the children are directly related to their immediate parent. So let's go ahead and give us some pretty obvious round numbers on this. Let's make that 3 and 1. So we're minus 3 units over and 1 unit back. Come back to the main character here. And as I move the main character around, you can see that that blob shadow is moving with it. Move to a completely new position. Look at the blob shadow, and we're still minus 3 and 1. So that relationship is maintained. Think about this with a car. If I had a car body model for a car game, and then I had a wheel or tire model, I would make that wheel a child of the car body. I'd then duplicate it 4 times and move them so they're in a relative position inside the wheel wells. And then once I've done that, I only need to worry about moving the car body around, and the wheels will come automatically. We would then, if we wanted to, worry about rotating those wheels or rotating and turning the front ones, but I wouldn't have to worry about moving the wheels themselves because they are children of that car body and will always be in the same relationship to the car body. Now, you can also make game object families that are not for mechanical purposes, as we've just described, but for organizational purposes. If we look up here, we see enemies. Enemy is a game object. It's got a header and a transform component, but it doesn't have any behavioral components underneath. And it's being used as a directory, as a folder, and inside it are where we're keeping a reference to all of our other enemy game objects. Same thing as we see here with our environment. We can see that inside environment we are keeping our barrels and our canisters and our catwalks, and inside that are the actual models. So I'm going to do a frame selected on catwalk. Oops. There we go. And so we can see that all of these objects, they're sort of probably not going to come through in the compression, but they're down here moving around. And we're using these game object families to be able to organize our hierarchy. So don't be afraid to use game objects for mechanical purposes and organizational purposes. In the game view, this is where the developer can play and test their game. We can play and pause and step through our game frame by frame. Currently, we have this on free aspect. Well, you can see our blob shadow moving around. We can change our aspect ratio up here to be one of the preset aspect ratios for our current platform, and this changes depending upon our build target. Or we can specifically pick a setting from our specific game, or go into free aspect, which will just fill the available space. We can, before we play, we can hit maximize on play. Come back here. And when we do that, we will fill the editor. And again, we have that same ratio choice that we have here. When we're in maximize on play, realize that we always see our footer and we always see our header, and then all of the rest is filled with the game view. We can pause. We can step through our game one frame at a time. And when we're playing our game, I think it's important to keep track of that console. Because here's where we're going to see errors and messages, either messages that we've put in our own code, messages that the developers of the frameworks that we've purchased will put into their code, or we will see Unity edit or runtime errors here as well. And so if we make a mistake in the way we've written our script, or if we make a mistake in the way that we've assembled our game, and we run into problems, Unity will put both warnings and full-on errors in this console, and we'll talk about these, how to deal with them, as we get further on in the lesson. We can see that the entire editor is rearrangeable and dockable, and we can save our layouts. Oops, come back here. So what I'm going to do is go ahead and rearrange this to the way I like to have it. What I like to do is I like to have my project view. I like to have my project view first, and I like to have this in single column mode up here. So this is all of the assets that I have to deal with. Then I like to have my hierarchy, which is the current scene I'm working on, and then I like to have the inspector, which is the object that I am inspecting. Which we could do things like come to our player, and there's our player. So I've got my project, all of my assets. Here's my scene. Here's the game object. I like to see my game and scene at the same time, and everyone can pick their own. Anyone can change these. You can have multiple layouts depending on what you need to do. And then once I'm going to leave console docked because not enough room on this single monitor here to show it. And then you can save it. Simply go to save layout and say, let's call this the demo layout. And once it's saved, it's in the list and we can pick it. So we can now go ahead and make changes. And if we don't save over these changes, we can then make a number of rearrangements, and then we can simply pick demo layout again, and it will reset it. Billy, yes, we will. Not just yet. A little while longer. So that's how Unity does it. That's the editor. Does anyone have any questions for the editor about the editor, or before we move on to game objects and their attached components? So we've seen what Unity does. It makes games. We've seen where Unity does it. It's here in the editor. And now we'll move on to how Unity does it. Scripting will be part 3. Yes, the layouts are saved between projects. They are editor specific. And so you can grow this list pretty extensively. And you can save them, you can delete them, and then you can revert them. And like I said, you can go ahead and you can make there's different changes. Here's the 4 split that are typical of top, front, and right, and then the perspective view. Some of these are just the default ones. This is one that I do when I'm recording tutorials for the Learn section, slightly differently. And then our current demo layout, which is very similar to the one I normally use. So let's talk about how Unity does it. Unity works by using game objects and their attached components. Gameplay is made by game objects and all of their components acting and interacting with each other. So to see this in action, let's start a brand new empty project. And we do that by going to File, New Project. This is the new project wizard and allows us to open existing projects. And if we move them, they're simply dropped from the list. So it'll remember the last known place, but if you go ahead and then you move the project and Unity can't find it, it'll simply drop it from the list. First thing we're going to do is set the path for our project. I'm going to save it on the desktop. I'm going to save it as Unity 101. Now, if I look at my desktop, I haven't created anything. I've simply set that path to being where I want it to be, but I have not made those. I've not made any project yet. In the main body here, we see a list of Unity packages, and these are compressed packages of assets. And if I want to have some building blocks preloaded and ready to go, I can select them from this list. And these building blocks come from either just the standard assets you get from downloading the editor. You can save your own Unity packages for use and reuse later. You can also make sure that the assets that you download from the asset store are here as well. So if I wanted to get a, say, character controller and some particles, physics material projectors, water, tree creator, I just select them from the list, and when I create the new project, all of these will be unpacked into my project view or my assets directory. But for our purposes for today, we're going to make sure that they're completely empty, and then we hit create project. Now don't be afraid about what you see next. It appears as if Unity crashes. It doesn't. It's just closed down the old project. It writes the new files, and then once they're written, it then reloads those files. And we can see that we now have Unity 101 on our desktop. And in it, the same files, slightly more limited because we've just gotten started, and there's our assets directory, and our assets directory is empty because we have no assets. And we can see that here in Unity because our project view is completely empty. Fox, let's talk about that in Q&A if it hasn't made sense, because we're going to cover some of that stuff just now. And if it doesn't make sense by the time we hit Q&A, then I'll go over the pipeline. It's normally something we wait for 102, but we're not doing a 102 this week, so I'll go ahead and give you some more information. Yes, the Ant Ranch. Funny history between why I have that name, but it's the name I called the company I was releasing games under is the Ant Ranch. So we've got this new empty scene. And it seems mostly empty. We've got a new empty project and a new empty scene. When we're reading our project, the first thing to do is look up here in the header, and this gives us the name of our scene, the name of our project, and our current build target. Now we're not going to be building anything today, but we are going to go over our build settings window just so you understand it. If I change my build target, currently I'm building for the default, which is PC, Mac, and Linux standalone. If I want to build for a web player, you can see that now up here we're untitled Unity 101 web player or iOS. So essentially, if you're reading the header, there's the name of our scene, there's the name of our project, that's our current build target. So if you ever get curious what scene you're in, what your build target is, hopefully you remember what project you're in, you can simply just look up here in the headers. Let's go back to PC, Mac, and Linux standalone. And when we start with a brand new empty scene, it isn't really empty. We always have a main camera. Why do we have a main camera? Well, if you think about it, we always need one point of view from which to render our scene and present onto the screen for our players, because if we didn't have a camera, we just have nothing. We have nothing to show. We can't show anything without at least one camera, and you can have many more cameras. You can have as many cameras as you want. Mostly we can talk about that in Q&A, why you'd want multiple cameras, but you need at least one camera to be able to render your scene. Now, our scene has not been saved, and that's implied by the fact that it's untitled. We could have saved our scene as untitled, but it's also, we know it hasn't been saved because our project is empty, and we save our scenes as scene files into our project view. The reason that the main camera is not an asset in the project, and we'll talk about that a little bit further on, is that there are a number of sort of templates that Unity has for game objects that are sort of reside internally inside Unity, and you can simply create them directly into your scene, including camera. So if I was to create a brand new camera, I could simply do that, and we'd have another camera. Other than its position in the game world, it's the same as the existing camera. So we don't need to have an asset with that because that asset's actually being held by Unity. So yes, I'm using Unity Pro. And so I've got the dark skin running because I find that it transmits a little better than the light skin. It's one of two things that I do that's pro only in this. All of the rest you can do with free. So technically the fact that you're looking at a dark skin is pro only. So the normal free version is going to look like that. Sorry, Felipe, come back. Send me an email to eLearning, especially if you're at GDC, which we can hook up. But we'll try to get you put back in, okay? So I'm going to go back and reset that back to the dark skin. So save early, save often, save before you play. My little save rant. Windows machines are stable, Macs are stable, Unity is stable, but we are working on a computer, and there is the chance that that you'll lose power. Someone will kick the power out. You'll just power outage, in which case your computer goes down. You could even, in theory, have that random cosmic ray slam in from outer space into your RAM, crash your computer. But more importantly, we're writing our own scripts and we're assembling our own scenes. That means that we could potentially push too much stuff into, say, memory, or we could write an infinite loop in our script. Unity will be happy to execute the code that we've written, including that infinite loop. If it did, we'd suddenly get the spinning gumdrop or beach ball on the Mac. We'd get to the rotating sand timer on Windows, and we'd have no choice but to force quit the application. And if we hadn't saved our scene at that point, then all of our changes have been lost. So it's just like saving a Word document or saving a Photoshop file or any one of these applications where you're saving your files. Your scene is a scene file, so make sure you save early and save often. The other thing that I would... right now, Unity does not autosave. It's a matter of debate. As to why you would or would not want to have autosave. Currently, Unity does not have autosave involved. I think there's some third-party frameworks that will do that for you that you can find on the Asset Store. And then we can talk about in Q&A how to open a feature request or vote one up that already exists, which I think that does. But also, I think that it's important as part of my rant to say, get some way to version your project. I was dealing with someone a while ago on the forum. They sort of posted that Unity had corrupted their project. It turned out that really what they were encountering was catastrophic hard drive failure. And they were losing bits on their hard drive, and those bits were underneath the project. Now, where this was very, very sad is it was one man working alone on a project. He'd been working on it for longer than a year, and he had no other backup. And he was able to recover some of the assets that he had created, but the project itself was unrecoverable, and it was catastrophic hard drive failure. So find a way not only to save your scenes, save early, save often, save before you play, but find some way to back up your project. This is not letters to you. This is not emails to your friends. This is something you're going to work days, weeks, months, if not years on. So drop it into Dropbox, put it into Google Docs. Unity works with Git, SVN. You can get the team license and you can put stuff onto the asset server. You can get CrashPlan to do backups. I use Time Machine. You can see this up here. I'm never more than an hour away. I've got a 2 terabyte hard drive slammed onto my machine, and every hour I get a backup. And I have loved the fact that it's there. And every time I've needed to go back and revert a project, it's because I've done something completely stupid. And the ability to go back and get my project from an hour ago is imperative. Victor, I actually should know that. And the answer is, I don't. Let me do some research and we can talk about it in Q&A. I know that you can enable metadata, and so I'm thinking that you can do this. I want to say yes, but before I put my foot into it, let me actually prove it. Because I know that you can enable metadata and for versioning software. If someone actually knows that for sure, then I'm just reluctant to actually say yes until I'm absolutely sure on that one. So anyway, that's the end of my rant. Save early, save often, save before you play, save your scene, back up your project, version your project, even if it's just simply copying it into another directory or another folder. So speaking of which, let's save ours. Let's save this. I'm going to save this in my assets directory. I'm going to create a new folder called _scenes. The underscore isn't necessary. It's for me because I like my scene files always to sort to the top. And then let's just call this one demo scene. And we can see that we've now created a folder called scenes, and there's our demo scene scene file. If we come and look at our desktop, we can see there's the scenes directory and the demo scene project there, or demo scene file. Yeah, I mean, that's what I'm thinking, Nicola, is that you can. Every once in a while I've said something definitive because I was sure I was right and then I wasn't. And for some reason I just felt like I wanted to check because my gut instinct says that yes, and I want to say yes. I think it's yes. Let me prove it. So let me just say yes and allow me to retract that in case I make a mistake. And we'll check that out in Q&A. So game objects. Let's talk about how Unity does it. Game objects. Game objects are holders. Game objects are containers. Game objects hold components. Game objects can hold any number of components. These components influence the behavior of the game object. Some components are mutually incompatible or are unique per game object. If you think about that rigid body component that we had attached to our player, we certainly wouldn't want the physics engine operating twice on the same game object, maybe giving it twice the collisions or twice the gravity. So sometimes you can only put one component onto a game object. Sometimes you can put multiple versions of the same component onto a game object. Now, game objects can also hold other game objects. When holding other game objects, a parent-child relationship is created. We create something we like to call a game object family. Transforms of all of the game objects in the family are relative to their immediate parent. By holding other game objects, a game object can be used as a directory or folder for organization in the editor. So don't be afraid to use game objects for organizational purposes as well as mechanical purposes. So let's take a look at a game object in detail. You create a new game object in your scene by going up to game object, create empty. And this creates an empty game object. Now, the first thing I want to say is a little bit like our new empty scene is not really empty. Our new empty game object is not really empty either. But we've got a header and one component. All game objects start with a header, and that header contains its active state and its name. And then all game objects must have a transform component. Transform component keeps track of its position, rotation, and scale in 3D space. And if we go to this little gear over here, it's a context-sensitive gizmo or gear gizmo. You notice that remove component is grayed out. This is the only component with remove component permanently grayed out, because all game objects must have a transform. We must know that not only does it exist, but where and how it exists and to what scale in the scene. Now, this seems to have come in at somewhat of a arbitrary position. We've got a rotation of 0, so we're aligned with the game world. We've got a scale of 1, so we're scaled properly, 1-to-1 to itself. But the position seems like arbitrary numbers. Why is this? Well, first of all, I think we should all come clean, because all of us are sitting in a class to learn about how to make games. And we must all admit, and what they always say is the first way to road to recovery is admission of the truth. we are all here to make a fantasy role-playing game. It is true. And if we imagine we're now making our fantasy role-playing game that we've all admitted that we are now going to make, and we're out in the far end of a corridor. Now remember, fantasy role-playing dungeons are made of two things: corridors and treasure chests. And so we have these corridors, maze-like corridors, and they're full of thousands of treasure chests that you open up and you take loot out of. And we're in the process of planting one of these treasure chests way out in the corner. We don't want our new game object to appear at origin at 000 in the middle of the game world. We want it to appear where we're working. So what happens is notice that this is arbitrary, but it's bang stab there in the middle of our screen. The new game object appears at the focus point in front of our scene view camera at whatever its current position and orientation is. So it'll always come in with a rotation and scale that's set to neutral, but its position will always be at the focus point in front of our scene view camera. So that's why we seem to have arbitrary numbers up here. What does the tag help with? We'll talk about tag a little bit further on, but yes, searching, finding, and identifying objects during the game itself. You basically can test something and say, is this game object the player or is this game object the enemy? And you can tag it. There's some default tags that come with the editor, and you can add tags. But we'll be doing that further on when we make our little mini game. So we can move our game object by manipulating it. We saw that by manipulating the handles, by manipulating the title, or by typing in numbers directly. So we can type in numbers. We can also grab and give them any arbitrary number that we want simply by grabbing and manipulating the title. Now, if we've got a bunch of random numbers in there, which we do now, and we want to remove these, we can go in and do them by hand. We can also use the context-sensitive gizmo. And here we can reset any one of the channels individually, like scale or rotation. On the other hand, if we simply want to put the whole thing back to origin, especially if we're, say, using this as a holder or container where we want all of our numbers neutraled out, we can simply reset the entire transform component, and we can see we've gone back to zeros and ones, hit F for frame selected, and we're focused in there on origin. So that object is now at the origin of our game world. So components. Components are what control a game object's behavior. Components are scripts when you boil them down. Many of the most basic components are pre-built for us by Unity, and these pre-built components have no visible or editable code. Can you add your own menu options to my components? If I understand you, you can. Give me 2 seconds, and let me get through components, and we'll talk about how you can manipulate them. And if you get to the point where you feel like I've bypassed that question, go ahead and ask it again. So we've got these components, and components are controlling the game object's behavior. And these components are scripts, but they're pre-built components that are made for us by Unity, and we can't edit them. We have no visible or editable code. Now, to see these, we can go up to the Components menu. And these are the components pre-built for us by Unity. We have mesh filters for holding meshes, mesh renderers for rendering them, effects like particle systems, trail, line renderers, lens flares, and halos. Physics, there's the rigid body, allows physics to happen on the game object. Character controllers, colliders to define outside shape, different shapes, boxes and spheres and capsules. We have cloth and joints. NavMesh, this is Pro, but we have navigation, AI navigation, simple AI navigation. Audio, listeners and sources, zones and filters for making things sound proper in our game. And then rendering, we've got cameras and skyboxes that surround our game with a graphic like the sky. We've got flare layers, UI layers, lights and light probes, and rendering and miscellaneous. Animator for Mechanim, and then animation for doing animation curves. Network view for multiplayer games. Wind zones for bending our grass, trees, and particles. And when we write our own components, they'll appear down here in a new tab called Scripts. We can also get to that same menu by going here. Now, so remember, we've got these menus up here: Assets, Game Object, and Component. And that's the same here. We can create game objects, so we can create assets, game objects, and we can add components here. So let's go ahead and just add one Let's add a component. You can just pick. Let's add a light. So we've now added a light to this game object. With only a degree, you can edit. You can edit the gravity, things like that, direction and the value of gravity. But in general, the physics engine it's the physics engine, and it is what it is, and it's tuned. And we'll talk about that in a minute. How it's tuned to Unity's unit system. So we've got a light here, and this light is a component that's now influencing the behavior of this particular game object. This gizmo shows the range of the light, and the way you read these is that, so this is a component, and there's a header. Click anywhere in the header. The turn down arrow will go ahead and show us whether it's open or closed, but we don't need to just click on the triangle. You can click anywhere in the header. And there's an icon that tells us to light whether that object, that component is enabled. This is whether the component is enabled, whether it's on or off. And then the type, which is light. And then on the left-hand side are properties, and on the right-hand side are the values associated with those properties. And so we can do things like change the range of the light by changing the value. And just like in transform, you can also do it smoothly by grabbing the title. We can change the color. We don't have anything to show, but if we zoom in, we can take a look at the gizmo, and we can see that the gizmo is changing color as well when we change the color of our light. So essentially, we have properties, the names of the properties, and the values associated with those properties here on the right-hand side. Now, if we look at the main camera, we'll see that we have the same setup. There's our main header. There's our transform, but it has a camera component attached with its values on its properties. And then down here we've got a UI layer, a flare layer, and an audio listener, but the turn down arrow shows us down, but we don't see anything. Well, that's because there are no exposed properties. There's nothing we can change as developers with these. They simply have one job, and they fulfill it by being attached. But we don't have anything that we can change. The only thing we can change is whether or not that particular component is enabled. So we could turn off the audio listener or turn off the flare layer, turn off the UI layer, but we can't set anything because there are no settings to set. So if we wanted to create a new game object, so speaking of which, let's name this one light. I don't need to call it light just because there's a light attached to it. I can call this anything I want to. I could call it watermelon. It's purely a title, and notice that I can change this either in the header of in the inspector, Captain Kirk, or I could change it in the hierarchy. So let's call it light because it helps us understand that this is a light. And if I wanted to create a new game object, say I wanted to make a sphere, I could create a new empty game object, and then I could add a mesh filter to it, and then in that mesh filter holds a slot. I could then add a sphere mesh, and then I could add a physics sphere collider. So we have an outside shape. Come on, let's move in. So there's the sphere collider, and then I could add a mesh renderer to render that, and then inside the mesh renderer I could add a material, give it a default material. And then with the exception of these funny numbers here, which are floating point decimal errors, which we can talk about in Q&A. It's not too bad. I made a little sphere, but a little tedious if I had to do this every single time, especially tedious when we consider that in the Create menu, Unity gives us a pre-built sphere. So this game object up here is my sphere. And if we look at Unity's sphere, with the exception of the different name, they are identical. So Unity gives us a list here of pre-built game objects, and these are essentially an empty game object with a header and a transform component, and then it has the components pre-attached and the values preset. So we don't have to go through and every single time add a new mesh filter, add the mesh, add a sphere collider, add the mesh renderer, add a material. We can simply ask Unity to give us a sphere. Why do I need a mesh filter if I have a mesh renderer? It's just the architecture that they've come up with, essentially that you have one component that simply holds the mesh data. In this case, it holds the mesh data for the sphere. And then there's another separate component that renders that mesh Now, whether this is because there's also a thing called a skinned mesh renderer that works with skinned meshes, which is slightly different from the mesh renderer. I guess it's just component-based architecture, where they felt it would be more robust to be able to hold that mesh filter with a sphere mesh in one component. Here's where the mesh data is, and have another component render it. Arguably, it would be also kind of neat just to have mesh renderers and have a slot that says mesh when you fill it. I don't know. Better. Yeah, Adobe Connect doesn't like this mic for some reason, and every once in a while I have to disconnect. So yeah, warn me if it happens again. So we have this sphere with its mesh, and so the blue lines are the mesh. Oops, come back here. So the blue lines are the mesh. The green lines are the mesh collider. And the blue lines are rendered by the mesh, because if we turn the mesh renderer off, we don't see the mesh, so that's when it's rendered. And remember that it's all these game objects and all of their components that are working with each other that create our game and gameplay. We can see that down in the game view, we see a little black dot. We get that because all of these game objects are interacting. We have the mesh, the little blue lines, in the mesh filter. The mesh renderer is getting that mesh data and using all of its information, including materials. It's talking to the camera. The camera is using all of its properties, including things like field of view, reading all of the properties with on its component. It's comparing the transforms of the two objects and rendering the little black dot. Even more complicated, the camera is not just talking to the sphere game object, which has the mesh renderer and the sphere mesh. It's also talking to the light. It's looking at the light game object, talking to the light component, reading all of the properties on the light, and rendering a little black dot. Now it renders a little black dot because one of the things that the camera is doing is comparing the transform of the camera and the sphere. It's comparing the transform of the camera and the light. It's also comparing the transform of the light and the sphere. And the light currently is inside the sphere. So it's not being able to light the surface. We simply make a change in our game world, and we change the transform position. The camera reads that and changes the way that the scene is working. So it's all of these game objects on all of these it's all of these components on all of these game objects and how they're acting and interacting with each other that gives us our game and gameplay. So we can save this scene, we can hit play, and nothing happens. Well, nothing happens because, well, we haven't asked anything more to happen. We're doing exactly what it should, which is that the main camera is looking at the sphere is being lit by the light, we see it. If we want more complex gameplay, we need more game objects or more components on those game objects. So if we took our sphere and we added a component and we were to go ahead and add, say, the physics rigid body, so now the sphere has mass, uses gravity, we hit save, we hit play, and the ball drops into the void. So now let me just turn this off. We've got maximize on play. Turn off maximize on play, and I'm going to back out a little bit on that ball. So let's hit save, let's hit play, and we can now see that ball is dropping into the void. So now ignoring the sort of the camera rendering pipeline onto the screen, what's happening here? Every frame now, we've got the rigid body component. The rigid body component is working with a physics engine. The rigid body component is working with the transform of this game object, and it's also working with the collider. The collider hasn't bumped into anything, so every frame it's going to be adding a value of acceleration to the sphere, and the sphere is going to accelerate at 9.8 meters per second squared, or actually negative 9.8 meters per second squared, down into the void. So every frame, that rigid body is interacting with a transform and giving it physics. Not quite I understand. As long as it's in the game, in which case it's in the game here, It's loaded. You need to be able, you actually have to say, I want this object removed from the game, and we'll talk about that during the game, but you have to destroy it. You have to physically remove it, because this, in theory, until it starts to run into some floating point issues, is just going to keep increasing this. Now, every frame we're outside of our view frustum, so it'll never be rendered. But the game will keep track of it, so it does have some amount of resources keeping track of that transform position of that sphere. So if we want more complex games, we can either add more components or we can add more game objects. In this case, we can say add a plane. We're going to reset that to origin, and then I don't want my ball buried into it, so let's lift that sphere up by a couple of units, maybe one more. So let's save this and let's hit play, and the ball comes to rest on the plane. Now, what's going on here? Well, our physics engine that we were dealing with before, remember, it's keeping track of our transform, it's keeping the rigid body is keeping track of our transform, it's adding a value to it until its sphere collider comes in contact with another collider, in this case the mesh collider. Let me turn off the mesh renderer, because the plane here is sharing the same mesh here. It's sharing the plane mesh between the two of these. It's sharing the same mesh, so the blue lines of the mesh renderer are just covering over the green lines of the collider, but there is a mesh collider under there. So every frame, that rigid body is not only adding to the y value into the acceleration, but it's also checking the volume of the sphere and making sure that nothing penetrates nothing penetrates the volume of that sphere. And so when it comes down to the next frame here, it bumps onto the plane. It doesn't allow the sphere to have and it does not allow the plane to penetrate the sphere, so it comes to rest on top of it. Now, what we're seeing here is the beginning of the architecture we would expect to see in a game, where we've got our mobile object. Here's our player. He has a rigid body on him. He's moving around. He's causing collisions. We have our game object down here, which doesn't have a rigid body. It has a static mesh collider, and it's simply acting as our environment. This is the hallway that we're walking on in our dungeon. This is the terrain we're walking on when we're above the ground. So we have our mobile object and we have our static object. And that's true even if we go over the edge. So let's go ahead and take a break. We've been at this for a little bit more than an hour, 8:15. So let's take a 5-minute break, real quick one. Sorry, but we've got a lot to cover. And let's take a break. And let's come back at 8:20. Okay, how about 8:21 by my clock? Somewhere around there. But I'll make it a quick break, wheeze coffee, that sort of thing, and we'll come back and we'll talk about prefabs. If someone has any questions, go ahead and throw it out there in the chat channel, and when I come back, I'll come by and I'll try to get them answered before we go back into the class.